Here we go. So this next part is we're going to finally be solving logarithmic equations. All right, so you have an equation with a log in it. How do I actually solve this thing? How do I finish the problem? How can I type it into my calculator even? So let's start by just reviewing the relationship between an exponent and a logarithm. For these two logs here, the one on the left, if I were to write that in exponential form, we'd write it with the base first, which is 2. Since logs equal exponents, and this log equals 4, that tells me that 4 is the exponent. And it equals the answer of x minus 3. Now, do you think you could solve this equation the rest of the way for x? Like, what would be our next step here on the left? Any ideas come to mind? Anyone? Solve it. Great. What would be your first step for solving this? Doing what? Exponent. That says 2 to the 4th on the left. Can I calculate what 2 to the 4th power is? Yeah, can any of you tell me what is 2 to the 4th? It is 16, right? 2, 4, 8, 16. All right, so let's rewrite this as 16 equals x minus 3. All right, what would be our last step here to get the x all by itself? And what's our answer going to be? 19, right? 19 would equal x. And guess what? That would be your final answer. You just solved a logarithmic equation. What do you think? Was that super difficult? You weren't even looking. You're chatting with your neighbors. Now, this logarithm on the right is a little bit different. I still want to rewrite it in exponential form, starting with the base. But, there is no base. What do I use in this case? Not 10. 10 is the common log. If you see ln, you use e for the base. So this is e is our base. That special number. Logs still equal exponents. This is e to the y, and it equals 1. Can we solve this? E to some exponent equals 1. Hey, what can I raise any number to and always get a 1? What exponent can you raise anything to and you get a 1? Anything raised to the 0 power will always equal 1. E is some decimal, right? 2.7. Doesn't matter. If I take a decimal to the 0th power, I know it will equal 1. So in this case, y has to be 0. You just solved another logarithm equation. Woo! This lesson's going fast so far. Now that we're done with the warm-up, let's begin. So we're solving logarithmic equations. A logarithmic equation is an equation with the word log in it somewhere. Pretty straightforward. And we're going to have 2 different types of log equations. First, there's a type of equation where you have the word log on just one side of the equal sign. The other situation is when you have log on both sides. So that's just what we're going to look at. Just to frame your reference. You don't need to actually write those equations down. I'm going to be going into separate slides for each of those scenarios. So this is learning target, 7.4. We actually just switched the order from last year because it makes more sense. So this is actually target 7.4. Solving logarithmic equations, which are just equations with logs in them. So this is what I do want you to write down under this heading. First, When you have a log equation with logs on one side of the equal sign, you're going to use those log properties to condense it into a single log. So just like the earlier lesson, if you have, log of this plus log of that, combine it to make it a single log on one side. When you have just one log on one side of the equation, we could just rewrite it in exponential form and solve it. That's exactly what we did with the warm-up today. So go ahead and write these steps down so that you can refer to them when you're working through some of these problems. All right, so pretty straightforward. Here's example 1. Got the log on both sides, or logs on one side. Which scenario is this? Do we have logs on both sides of the equation or logs on one side? Okay, just on one side. So if you think of this equal sign as being a wall, look, there are only logs on the left side. So we want to then combine those. Instead of having 2 logs, I want to write that as 1 log. Do we know how to combine 2 logs that are being added? So we just went over earlier today, right? So what do? How do I combine the 8 with the x if the logs are being added? That's multiplication. Good. So we're going to write this as log base 2 of 8x equals 6. All right, that's your first step. Just combine the logs. If they're being added, you multiply those answer portions. If the log is negative, you would divide those. Nice and easy. At this point, are there any more logs that we can combine? Nope, I just have 1 log, and I've got my 3 parts, the base, the answer, and the exponent. Once you get it to this setup, go ahead and rewrite it in exponential form. So this would be 2 is the base. What's my exponent? Logs equal exponents. This log equals 6. So 6 is my exponent. 2 to the 6th would equal this answer portion of 8x. So now that we have rewritten this in exponential form, it's actually pretty easy to solve. Because I can calculate this. I can take 2 to the 6th power. What would that equal, by the way? Does anyone know what 2 to the 6th is? Yeah, it's 64. 2 times 2 times 2 times 2 times 2 times 2. So this is just, I'm going to just write it over here. 64 equals 8x. Now, can any of you solve that for x? Of course you can. What do you do to both sides? Divide. Yes, that's right. Just divide. You got it. So 8 equals x. So that's solving your log equation when there's a log on one side. Any questions before we move on? All righty, here we go. Oh, look at this one. Go ahead and jot this down. If you want to stand up to solve it, that's fine too. If you're so excited, or if you're falling asleep, by all means. Josie, Alex, Connor, why do you keep turning your webcams off? If you do that again, I will mark you unverified. That is the policy. So just use those log properties to combine all three logs on the left into a single logarithm. So start off by just combining those. Remember, positive logs go on top, negative logs go on the bottom. Good. So when they're being added, you multiply. A negative log would be divided. So it's all those properties from the first lesson today. So use those first to combine it. So I saw most of you got at least this far of combining your logs. The two positive logs are the 50 and the x. So those both would be in the numerator being multiplied together. The one negative log, 2 log of 5, I'd take that 2 and make it into an exponent so that it's 5 to the second. But since that log is being subtracted, it has to go into the denominator. Can I simplify that fraction at all? Do you think? Like, we know what 5 squared is, right? 25. Then I have 50x over 25. Does that simplify nicely? Sure does. This is the is a 25. Then 50 divided by 25 is just 2. So that'd be like log of 2x equals 3. Did anyone else get to that point? Log of 2x? Just simplifying the parentheses, right? That just makes it a much easier problem for us. It's fewer things to work with. So I've got one log on one side. That's great. That was our first step. Our second step is to rewrite it in exponential form. To do that, I start with the base, but there is no base. There's no subscript here. It just says log. So what do we use for a base in this case? A 10, correct, right? This is the common log, base of 10. So we'd rewrite this with a base of 10. My exponent is 3 because logs equal exponents, and this log equals 3. Therefore, 3 is the exponent. So 10 to the third equals 2x. From here, you just solve for x. What's 10 to the third power? Yeah, that exponent, that's just how many zeros you have. So it's 1, 0, 0, 0. With 3 zeros, that's 1,000. So 1,000 equals 2x. 1,000 equals 2x. There we go. Then if we divide by 2, we see, oh, that's just a 500 equals x. Anyone get that? Anyone get 500? Fantastic. Oh, that's awesome. Good job. All right, so this is when you have a log on both sides. Spoiler alert, this is going to be easier. And that first way wasn't that difficult, right? It's going to be fine. So the other type of equation we can have is when there's a log on both sides of the equal sign. First step, pretty similar. We use these log properties to combine logs on both sides. So now I'm going to have some logs on the left, combine them to make a single log. Then you're also going to have some logs on the right side, combine those to make it a single log. When you do this, then you're going to have an equation with the log of something equals the log of something, where you have one log on the left and one log on the right. Now the super nice thing is, if you've got log on one side and log on the other side, ultimately, we can just cancel out those two logs. And just those two answer portions, you know, the part that's like in parentheses, you just set those equal to each other and then solve it like a regular equation. So it's going to be a lot easier because of this, because you just cancel those logs out. And it's just like a regular equation. Might be a linear equation. Also, fair warning, it might be a quadratic equation, so you're going to have to do some factoring, but you're all pretty good at factoring at this point. And if not, it'll be super duper practice for you. So go ahead and jot this down. Log base 6 of x minus log base 6 of 3 equals log base 6 of 4. So let's look at the left side. I have 2 logs. The right side, there's only 1 log. So the right side's fine. I leave that alone. On the left side, I have 2 logs. Can we combine that into a single log? Do we have a property for that when you're subtracting 2 logs to make it 1? Yeah, what operation do we do for subtraction? Quotient property, division. So we're going to write this as the log base 6 of x divided by 3. Because the x is a positive log and the 3 is a negative log. So the 3 would move to the denominator of that single quotient. Nothing changes on our right side. That's still log base 6 of 4. So I just used the quotient property to combine those 2 logs that were being subtracted from each other into a single log that's being divided. All right, so here's the easy part, everybody. Log base 6 on the left, log base 6 on the right. Just cross the logs out. And all we have is x divided by 3 equals 4. And oh my golly goshness. Can anyone solve that equation for x? Fingers crossed. I hope all of you can do that. I know you're all extremely bright individuals, capable of solving this problem. Want to get the x by itself. It's being divided by 3, so let's multiply by 3 so that those cancel out. But then I'd have to multiply the right side by 3 to keep things balanced. And our final answer for this is that x must equal 12. Dun, 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 dun. That's not bad, right? I tell you this is going to be easier. Like I said, on your homework for these ones, you will get some quadratics. When you set each side equal, set it equal to 0, and you'll just have to factor to get your 2x values. You know, it multiplies to this and adds to that type of a thing. We can just laugh at this, right? They're all the same base. So what do we know is going to happen? We can combine them, and then we can cancel them out, right? Because you have logs on both sides. So I don't know, I guess take a minute just to write out this problem because there's like a million things there, and then we'll work through it together just so you have it in your notes. If you're feeling brave, please, by all means, go ahead and try solving it, but I'm going to walk through it with you. I know it looks gross right now, but it works out so nicely. Does everyone at least have it written down? Coefficients become exponents. And just a reminder that an exponent of 1/2 is the same as a square root. So both of these 1/2s, when they become exponents, it's actually going to be the square root of each of those. So I'm going to write this as the log base 13 of the square root of 12 times 3, because it's being added. What is 12 times 3? 36. Hey, look at that, a perfect square. I told you to work out nicely. Equals log base 13 of, now this one we've got subtraction in it, so anytime you've got a negative log, you put that answer portion into the denominator. So the x plus 4 stays up top, but that 2 would go in the bottom. I have one log on each side. They have the same base. Can I go ahead and just cross those out then? Sure can. So log base 13 on the left, log base 13 on the right. So the square root of 36, which we know is just a 6, because that's a perfect square, equals x plus 4 divided by 2. And here we have a pretty straightforward math problem. Do I get rid of the 2 first or the 4? The 2. Since all of those are being divided by 2, I want to cancel that all out by multiplying by 2. So we get 12 equals x plus 4. Subtract 4 from both sides, and x equals 8. Isn't that crazy? Yeah, I hope that's not an extraneous solution. Wait, what? Checking our answer. Well, that's not something we've done in units. I mean, that was months ago, right? I'm sure there's no such thing as an extraneous solution, right? No, I mean, this is pretty straightforward. Don't worry, it works for this one. Okay, one last note on that extraneous solution thing is you cannot take the log of a negative number. It doesn't work. So if you ever were to like plug something back into that original problem and it would give you a negative log, you'd say, no, that doesn't work. That's extraneous. So like that last one, we got x was equal to 8 for that problem that we just solved. If one of your original logs was something like, I guess 2 minus x. Okay, let's say this was one of the original logs from the very original problem. And we solved it, and we got the answer, oh, x equals 8. You're like, box it up, we're done. You do have to check a little bit very easily. You don't have to resolve the whole problem. But just think, hey, if you were to plug that in for x, would that make the part in parentheses negative? So in this case, what's 2 minus 8? It's a negative 6. You get, oh, that's a log of negative 6. That can't happen. You cannot take the log of a negative number. So then that would be an extraneous solution, which means there is no solution in that case. Then I do just want to preview your Delta Math for you tonight because you've got 2 assignments because we covered 2 whole lessons today. So you're going to be doing some math work tonight, everybody. And that's okay because you didn't do any math homework last night. You know, it's just going to make up for it. I wouldn't want you to go too long without doing any work. So take a look at this. (7.3) properties of logs. So you've got some condensing logs and expanding logs. So condensing logs, you're just rewriting as a single logarithm. Look that it already has the word log written for you. And so you're just combining it to write it as a single log. Expanding it, so you've got multiple bases, you write it out as multiple logs. So, hey, those are being multiplied, write it as addition. Any exponents move in front to become coefficients. For the log equations, so everybody, these ones, solve for x. What would you do for this? What's your first step? How would you rewrite this equation? Exponential form, right? You go like 4 to the 4th power equals x. Well, that's just number, 4 to the 4th power. You can calculate that. See, so change it to exponential form. 4 to the 4th equals x. So x would have to be 256. All right, so you're just rewriting these first. These log equations, now you're just doing what we just kind of did up on the board. So you've got 2 logs, rewrite it as a single log. And then if there's a log on only one side, you'd rewrite it in exponential form. And it shows you right here. So even if you get it wrong or you get it right, it shows you those steps. So combine it into a single log and then rewrite it in exponential form and then just solve that for x straightforward. And then the last one, some natural log equations. So solve for the exact value of x. Since this ln would have a base of e, and e is an irrational number, that means you're going to write your final answer with the letter e still in your answer. So here, when you rewrite it in exponential form, you're going to get 5x minus 1 equals e to the 4th. And so just get the x by itself. So like you would add 1 to both sides. That'd give you e to the 4th plus 1. And then if there's a 5 in front of x, you would just divide both sides by 5 to get e to the 4th plus 1 divided by 5. And that is how you would write your final answer for these, okay? So it's actually a little bit easier. You don't have to do any actual calculations. But when it says exact answer, it means leave e in your final answer, because otherwise you'd have to round it off a little bit, so it wouldn't be exact anymore. All right, think you can handle that tonight? They're pretty basic, and these lessons were all pretty easy, but you've got to just practice it to make sure you've got that locked in, all these new properties. All right, best of luck, everyone. I believe in you.